Cola makers test new recipes for loss of sweetness during storage. Trained testers rate the sweetness before and after storage. From experience, the population distribution of sweetness losses will be close to normal. Here are the sweetness losses, sweetness before storage minus sweetness after storage, found by tasters from a random sample of 10 batches of a new cola recipe. So there's our data points. Are these data good evidence that the cola lost sweetness? Carry out a test to help you answer this question. All right. So our statement would be we want to perform a test at H naught is mu is equal to 0. So basically the average loss of sweetness, there is no average loss of sweetness, versus the alternate hypothesis where the average loss of sweetness, there is an average loss of sweetness, right? The mean is bigger than 0, where mu is the actual mean amount of sweetness loss. We will perform the test at the alpha equals 0.05 significance level. So our plan is, if conditions are met, we should do a one sample t-test for the population mean mu, and it falls into this category here. Our sample size is less than 15. We can use the t procedure if the data appears close to normal. And the reason why we can do that is because we do have 10 data points, and it is close to normal. It's given in the problem, right? Okay, so let's go ahead and do our tests. So the first one is random, right? So it was given that the sample was randomly selected. Okay, so that one's good. Now let's check independence, or I'm sorry, normality, right? Normal. But of course, it said that in the problem, so previous experience tells us that sweetness losses will be close to normal. And that was given in the problem. Problem. All right, so we have our normal condition. Now let's get our independent condition, right? Independent, or otherwise known as our 10% condition. Okay, so we have n is equal to 10, right? That's the number of samples we have, or the number in our sample, right? And capital N is the total number of batches, right? So we have our inequality, n is less than or equal to a tenth of big N. So we have 10 is less than or equal to a tenth of n. So, in other words, we have 100 is less than or equal to n. And I think it's safe to assume that there are more than 100 of these batches. All right, so we have all conditions met. Conditions are met. Okay, so now let's do, so the sample mean and standard deviation are, because we need that for our test statistic. Okay, so as you can see, I already put in the data. Here's my data that's in our problem. And let's go ahead and do our menu, statistics, stat calculation, and one variable statistics. It's in A column, and we want our results in the B column. So there it is. So X bar is 1.02, and the sample standard deviation is 1.196. Okay, so we have our X bar was 1.02, and our standard deviation, our sample standard deviation was 1.196. All right, so our corresponding test statistic is going to be T is equal to X bar minus mu naught all over the standard deviation of x over the square root of n. And then that's going to be 1.02 minus our null mean, which was 0, over 1.196 over the square root of 10. And that gives us 2.70. Okay, so since this is a one-sided test with degrees of freedom equal to 10 minus 1, which is 9, the p-value is, so we want the probability, our p-value is going to be the probability that t is bigger than 2.70. So let me move this a little bit. Oh, let me just erase this, because it's going to be between two values. So the probability that t is bigger than 2.70, it's going to be between two values, and I'll show you what I mean when I get the table. All right, so our degree of freedom is 9, and we want 2.70, right? So 2.70, so that's between this one and this one, right? So we know our probability is going to be between 0.01 and 0.02, right? So that's where our probability is going to be. So it's going to be between 0.01 and 0.02. So clearly, if our p-value is between 0.01 and 0.02, this means that the probability, our p-value, the probability that t is bigger than 2.70, is less than alpha, which is 0.05, right? So we can conclude, since our p-value is less than alpha, which is 0.05, we reject the null hypothesis. So it does appear that there is an average loss of sweet for this cola.